Okay, question 21. Diagram 5 shows the setup apparatus to purify impure silver that containing copper as impurities by electrolysis process. So what is they told you that this is silver. Okay, so but the silver got a bit dirty lah, not so pure, not so clean lah, because outside containing some of the copper layer, which they want to take up the copper layer. They want to remove it. They want to get the pure silver metal. So this one is the impure silver, right? How do they make it clean? They use this process called electrolysis process. So it means this cell is called electrolytic cell. So if you remember, electrolytic cell, anode is positive, cathode is negative. Which side is anode? Which side is cathode? Remember, we normally want to sacrifice the impure one. Okay, we want to make sure the impurities, like here is copper, the dirty things like copper, have to dissolve into the solution. So that's why what happens is impure metal normally connect to anode, which is positive terminal. Pure metal, pure silver, connect to cathode, negative terminal. So if we use silver in the electrolysis process, what is the electrolyte that should be used? Very simple. Okay, here the title is M nitrate, but the best for the nitrate is, since they told you it's already silver, so you just put silver nitrate solution. AgNO3 solution. Now I explain to you. Okay, what happened is this reaction actually is very simple. So what happens is this silver Ag, because you know, right, anode undergoes oxidation. In Malay, it's called pengoksidan. Ag will dissolve into the solution, become Ag plus. Silver atom dissolve becomes silver ion. At anode, at cathode, what happened? Cathode undergo reduction by receiving electron. Silver ion receive electron go back to silver. So the half equation is so simple. For anode is Ag become Ag plus. For cathode, Ag plus receive electron become Ag. That's it. So they ask you to draw the battery. So on the space on here. So simple. Okay. Electrolytic cell, anode positive, cathode negative. So how you draw? The long one, like this one. Long one you draw at the left side. Short one you draw at the right side. That's it. This is B. C. If the initial mass of the pure silver metal electrode used is 25.3 gram, and then after 30 minutes, the final mass of the pure silver metal increases to 36.1 gram. It means you know what is happening, right? What is the observation, right? The observation is, of course, the silver metal here, the impure metal, will dissolve into the solution and become thinner. This one become thinner. And not become thinner, cathode become thicker. Or you can say, why is it thicker? Because now you got a lot of silver formed at the silver metal. The new silver layer is coating around the original pure silver metal. So that's why the size look even bigger. What is the color of silver? Gray solid. That's why you can say gray solid is deposited. Or you can say the electrode become thicker. So it means original is 25.3 gram. After the reaction become 36.1 gram. Okay. Find the number of mole of silver that has been extracted from the impure silver metal. It means what actually happened is the impure silver here will dissolve, and after reaction, after dissolving, and goes back to here. Anode will sacrifice this silver just to make this become thicker. So they're asking is how much of it from here goes to here. So simple, you just minus off. Okay, because number of mole means mass over molar mass. So actually it's so simple. Okay, first of all you find out what is the mass first. Okay, it's not initial, it's not final, it's how much that has go from anode to cathode. So you can just minus off first. 36.1 minus 25.3, you get 10.8 gram. This is 10.8 is from here extracted to here to make this become thicker. And then use this mass to find number of mole. So the formula is number of mole equals to mass over molar mass. So the molar mass, the sheet will tell you one silver is 108. So you use mass over molar mass. Easily you get 0.1 mole. So only can get 2 marks. But you have to understand what the sentence want. How does it work? One mark, finding the mass of that has been extracted. The other mark, find number of mole using mass over molar mass. In Malay is GSIM divided by GSIM molar. Write the half equation for the reaction that occurs at the anode and cathode. So what happened to anode? Very simple. Just now I told you, right? Silver will donate electron, become silver ion. So literally, you can just write Ag arrow Ag plus donate 1 electron. So you always throw the electron to the other side. What happened to cathode? Cathode, the silver ion will form silver. So the Ag plus receive electron become Ag. Now, I can explain even furthermore. Why is it Ag only? Why? I thought here got ion 1, the electrolyte inside got ion. I thought the ion is silver nitrate solution is Ag plus nitrate ion. Solution means got water, hydrogen ion, hydroxide ion. Then you know that cation ion goes to cathode, anion goes to anode. So then you have to choose one ion, right? Since the E naught value of silver ion is more positive, remember? Then that's why we choose silver ion to undergo reduction, become silver atom. But for anode, you got 3 factors, right? The first factor, remember? The first factor is which one contain active electrode? Do you have active electrode? Copper or silver? Is your electrode using silver? Yes. So that's why we straight away choose the first one, first factor. We don't choose the ion, we choose silver to undergo oxidation. Unless you don't use copper silver, here you change to carbon. That will be a different story. Then only you look at the second factor, concentration of halide ions. Whether they are more than 0.5 mole per cube. If not, then only look at the factor, whether their E naught value is which one is more negative. For cathode, only got one factor. Just like I told you, right? Cathode only got E naught value more positive. That's it. Of course, you always choose this factor for cathode. For anode, since you got active electrode, so you choose active electrode to undergo oxidation. Now this one let me check it. Okay. You still have to use this. You have to use this factor, isn't it? Okay, you have to use this factor for anode and for cathode. Copy down first. So I show you. So anode got 3 factors. Cathode only got 1 factor. So you look at this properly. They say diprotic acid R. You know what diprotic means? Diprotic means one acid molecule produce 2H plus. Because again, as if you see acid, always contain hydrogen ion. Always contain hydrogen ion. So you know it's already acid, right? The cation ion is already H plus. So you already can know what kind of gas coming out at cathode. So simple. Normally, hydrogen ion turn to what? Cathode will receive electron, right? Undergo reduction, receive electron. When they receive electron, become what? Hydrogen gas. Balance equation. As simple as that. Yeah. That's why these two are called colorless gas is released. If you want even further for the test, you put the burning wooden splinter, then you got pop some produced. Simple. You already know they produce hydrogen gas because doesn't matter with diprotic or monoprotic, they all have hydrogen ions. It's just that this one monoprotic means one acid molecule produce 1 mole of hydrogen ion. This one acid molecule produce 2 mole of hydrogen ions. Then anode, here we come. Okay, so they say colorless gas is released. Now, you think properly. Do you think it's possible for first factor? If let's say if your electron is using copper and silver, do you think you got gas coming out? No, right? If you use active electrode, normally, let's say if Cu undergo oxidation, it becomes Cu2 plus. So the electrode will dissolve, it become thinner. This one same. The electrode dissolve, become thinner. So nothing to do with gas resonate. It's just the electrode become thinner. So it's like first factor already out, isn't it? Already out. Second, Cl minus, Br minus, I minus. Now, do you think it's possible for acid up? No, right? Not possible, right? Do you know why it's not possible? Now, let's say if you choose this ion to undergo oxidation, because anode undergo oxidation is by releasing electron. Think about it. Cl minus change to Cl2. Cl2 is what gas? What color gas? Greenish yellow gas. What it is bromide? Br minus change to Br2. What is the color of Br2? Brown gas. How about I minus? I minus change to I2. Also, you will get brown color solution. So all of them, the product all have color, but this one that gives no color. So the only thing that can follow is number 3, isn't it? For acid R, number 3 is it? E naught value more negative. Now you must ask, how do I know which ion exists? Think about it in form 466. What is an example of diprotic acid? The formula that contain H2 something. H2 SO4 sulfuric acid is a diprotic acid. One acid molecule produce 2 mole of hydrogen ion and 1 mole of sulfate ion. So it means the negative ion here is sulfate ion. And as I told you, right, acid need to ionize in water, then only can produce hydrogen ion. So it means acid mixed with water. Water is H2O, right? Containing hydrogen ion and hydroxide ion. So it means, which also means Fe not only contains sulfate ion, also contain hydroxide ion in this case. So then you might ask me, wait, what is the E naught value of hydroxide ion and sulfate ion? Now, normally if you see like sulfate ion, doesn't matter lah. A lot of this ion, sulfate ion, chloride ion, iodide ion, nitrate ion, a lot of this ion, you always don't choose. You always only choose hydroxide ion. Because hydroxide ion normally, the E naught value is less positive, or you can say more negative. So because hydroxide normally contain positive 0.40 volt, sulfate ion, the E naught value is positive 2.01 volt. So which one is more negative? Hydroxide ion. So it's like in this case, here hydroxide ion is the one that being oxidized become what? Now, how do we even write the equation, the half equation? Hydroxide ion become oxygen, water, donate electron. Remember, OH minus got 4. 4 OH minus. Then, here also should have 4 hydrogen in water, so times 2. 4 negative charge. That's why the electron also should be 4 electron. This is the equation for the anode part. Okay, so what gas produced? Oxygen gas. That's why you got colorless gas released, which is oxygen in this case. The other side is hydrogen. Both sides is hydrogen, both acid is hydrogen, but for the anode, different. Here, monoprotic acid M, greenish yellow gas released. Obviously, it's not possible for first factor. First factor don't produce gas. The only possible is second factor. Check. Which one is greenish yellow color gas produced? Which ion? Cl minus. Cl minus. So what is the possible acid? Okay. Now same thing. Actually, this acid also contain. You have to put inside water, right? Also contain hydroxide ion. But even though the E naught value for hydroxide ion is more negative, we don't choose because in this case we prioritize the second factor first. So that's why we choose, because of this factor, concentration more than 0.5 molar cube. Okay, that's why you got greenish yellow gas released. This is Cl2 coming up. That's why if Cl minus is the one undergo oxidation by donating electrons, become Cl2. Then Cl2, since you got 2 molecules, right? At the front for Cl minus times 2. Now you got 2 negative charge. Electron also should be 2 negative charge. If they ask to write half equations, you have to know how to write. So the correct acid for acid R is sulfuric acid. Acid M, H plus and Cl minus, HCl. Name, you cannot write formula. Hydrochloric acid. This part might be challenging if you don't understand. So, yeah, this answer.